Today's lesson is on statistics. So I'm going to go over basic vocabulary. Your mean is your average. To find your average, you add up all your data and divide it by the total number of pieces of data that you have. The median, if you line up all the data in order, which number would be in the middle? The mode is the number in the data that shows up the most. So find the mean, the median, and the mode for the following data. So I can take my calculator and I can add all my data together. And divide by the total number and get 7.6. So my mean is 7.6. To find the median, I need to line it up in order and find the middle number. And then find the middle. I missed a number. Oh, let's see. 14. Oh, I missed my 12. Sorry. There's a 12 in here. So he'll cancel with him. And that'll be the 8. 8 will be the middle number. And the mode is the number that happens the most. I have 3 5s and 2 8s, so the 3 5s win. Now there is a way that your calculator will do this for you. It won't find the mode, but it will find the mean and the median for you. So if you go Stat, Edit, clear out anything that's in there, and enter in your data, and it does not have to be in order. So this will save you some steps. And then quit, and then go back to Stat, go over to Calc, and number 1, I want to do one variable stats. So the very first thing you see, which is X bar, which is the 7.6, that's your average. And then way down here at the bottom, see the arrow? That means if you arrow down, there's more information. If you go all the way down, you can see the third one from the bottom, the MED, that's your median, which is 8. I don't think I wrote my decimal very well. So your mean is 7.6, which you can get from your calculator, and the median is 8, which you can get from your calculator. So the only thing that you really have to find by hand is the mode, which is very simple. It's just looking to see which number happens the most. So the following data represents the algebra test scores of 20 students. Find the mean, the median, and the mode. Stat, clear out, and okay. Quit, Stat, Calc, one variable stats. So my X bar is the average, the mean, 74.8. The median, I just have to scroll down. It's the MED, 77.5. And the mode, I'm just going to find the one that happens the most. I've got a pair of 67s, and a pair of 90s, and a pair of 91s. So all 3 of them, because they all happen twice. Okay. A whitewater raft can hold a maximum of 1,000 pounds. What would be the best measure of the people's weight to know if an entire party can go on a whitewater trip? So the median would be the middle weight. That's not going to let me know if I can have everybody go. The mode is the one that happens the most. The mean is the average. The range, your range is just your biggest person minus your smallest person. But if I have 1,000 pounds, I really want to know everyone's average weight or the average weight of everyone, because then I'll be able to tell based on how many people I have if I'm under 1,000 pounds or not. So we're going to go with mean. If you were going to open a lemonade stand on your street, what would be the best measure of data to use when deciding to run your stand in relation to the number of cars passing per hour? So if we go and set up like a 10 to an 11 o'clock hour, and 11 to 12, and 12 to 1, and 1 to 2, and let's say 2 to 3. And then we do tally marks. So let's say we have one of those, and one of those, and another one of those, and a couple of these, and 6 of those, and 3 of those, maybe 7 of those. Okay, so when do you want to be out there? Well, you want to be out there when you have the most number of cars going by. So this one has the most number. So I would have more 11 through 12 o'clock times listed. So I would want to be out there in the 11 to 12 o'clock hour because there's 7 cars. So I want the mode, the one that happens the most. Dot plot shows the ages of students who are on the debate team. So their ages range from 13 to 18. Most of them are 18-year-olds. I have one 13, a couple 14-year-olds. It says, what is the median? The median is the middle. So I'm just going to start crossing out until I find the middle. And it doesn't matter if you start at the top or at the bottom of a column. And it ends me with those two. So the middle would be the middle of those two, which would be 17. Okay, box and whisker, you've got quartiles, which are percentiles that divide the data into force. So your first quartile holds 25% of your data, and your second quartile also holds only 25% of your data. The 50% is here because that represents everything up to quartile 2. Then in between quartile 2 and quartile 3 is 25% of my data, but all of that is going to be 75%, and then this top part is 25% of my data, and all of that would be 100%. Quartile 2 is your median, so he's your middle, not your average, he's your middle. Quartile 1 is the median of the lower half, and quartile 2 is the median of the upper half. Your range is just your maximum piece of data minus your minimum piece of data. The interquartile range, otherwise known as the IQR, is the middle 50%. So that's, this is getting kind of messy, but it's this part right here. So it's your middle 50%. Because remember, this is 25%, and so is this. So that's going to be Q3 minus Q1 to find your middle 50%. So here we go. We've got our 5-number summary, which is the lowest value, which is going to be your minimum, your Q1, your median, which is Q2, your Q3, and your highest value, which is your max. We can use these 5 numbers to create a graphic sketch of the data, which is called a box and whisker. It's a simple way to visually organize the 5-number summary. So to make a box and whisker, I put my data into my calculator and I find my 5-number summary, which is on your calculator. And it's right here when you do this screen right here. It's your min, your Q1, your median, your Q3, and your max. Those are your 5 numbers. Make a box using Q1 and Q3. Your lowest value is your min, your highest value is your max, and the line down the middle of your box is your median. So let's practice doing that. The following data represents the number of turnovers in a basketball season for a particular team. I want to find the 5-number summary and make a box and whisker. So I have to take my data and enter it into my calculator. Okay, quit, stat, calc. And I don't want this stuff at the beginning. I want it all the way down here at the end. So my 5-number summary is going to be 10, 12, 17, 24, 33. 10, 12, 17, 24, 33. 10, 17, already forgot. 24 and 33. Okay. So you need to scale at the bottom. I'm going to go start from 10. I'm going to go to 35 because that'll cover all my data. I'm just going to go up by 5s. And then I'm going to put a dot at all my 5 numbers. So I've got a 10, I've got a 12, I've got a 17. That's not a dot. I got a 24, and I have a 33. So my last quartiles are my whiskers. My inner 2 quartiles are my box. And then I have a median that goes through. So again, this is my min, and this is my max. This is my median. Everything that's inside this box is in my IQR, my interquartile range. 25% of my data lives out here on this whisker. 25% lives in this part of the box. 25% lives in that part of the box. And 25% lives on that whisker. Now my whiskers are very uneven. That doesn't mean that this longer whisker holds more data. It just means that that data is much more spread out. And the data over here on this whisker is much more compact. So what is the range in the IQR? Well, the range is the max minus the min. Okay, and I can look at my box and whisker, or I can just look at my 5-number summary. My max is 33, and my min is 10, so my range is 23. My IQR is the box, so Q3 minus Q1. So it's this guy minus this guy. And again, I can look at my 5-number summary, 24 minus 12, so my IQR is 12. Use the following box plot to answer the questions. What is the interquartile range? Well, this one's kind of off a little bit, so we're just going to kind of round to the nearest number. We're going to say that's 27, and we're going to say that that's really close to 24. So my interquartile range is 27 minus 24, which is 3. My maximum looks to be 30, and my minimum looks to be 22. So my range would be an 8 if I were to subtract those two. Which data set could be represented by the box plot below? Well, I know that I have a minimum of a 5 and a maximum of a 15. So I can't have a 16 and a 4 in here because my box plot shows all my data. So he's out. Now, none of the other data have any numbers beyond a 15 or a 5, so it's not going to help me anymore. So now what I'm going to do is I'm going to take each of my answers and I'm going to plug them into my L1, and I'm going to get their 5-number summary. So if I take the first one, is that it? Yeah. Okay, and let's get his 5-number summary, and I want it to match the box and whisker that's up here on the board. So 5, 6, 8, 12, 15. 5, 6, 8, 12, 15. There's my winner. Because he has the same 5-number summary as what's listed up here, It has to be that one. And if I tried C and D, if I plug them in and get their 5-number summary, one of the numbers would be off, so it wouldn't work. The box plot below represents the number of hours Joey worked each week for 20 weeks. What is the interquartile range, the IQR, and that's Q3 minus Q1, which is the box. So we're going here, which is 25, minus 14, so 11. Box plots for 4 competing brick manufacturers are shown below. A contractor needs to buy bricks that are each as close to 2.5 inches high as possible. Which manufacturer would be the contractor's best choice? Most of the people pick Adam because his median is really close to 2.5. But it says are each as close to 2.5 inches as possible. Well, look how far spread Adam's bricks are. Like those are the heights of his bricks, and those are really, really spread out. So I want something, yes, that's close to 2.5, but I want them to be consistent. So I really want the least spread out data possible, and that answer is Daniel. A movie theater recorded the number of tickets sold daily for a popular movie during the month of June. The box and whisker plot shown below represents the data for the number of tickets sold in hundreds. Which conclusion can be made? The second quartile is 600. Well, here's 600, and that's the third quartile. The mean of the attendance is 400. Well, in a box and whisker, that's not the mean, that's the median. You don't know anything about the mean from looking at a box and whisker. The mean is not on there in any way, shape, or form. The range of the attendance is 300 to 600. Well, here's 300 and there's 600. That's not the range. Now, that's the interquartile range. That's the IQR. But my range would be from 1 to 9. 25% of the attendance is between 300 and 400. Here's 300 and here's 400. And that's 25% because that's one of my quartiles. A chairlift can hold a maximum of 40,000 pounds and around 200 people. A safety inspector is determining if the chairlift is safe or not. Which measure of central tendency with people's weights would be most useful to determine the chairlift is safe? And again, that's going to be your mean. We need your average weights. Based on the box and whisker plot below, which statement is false? The median is 7. There's the median. It's right at 7, so that's a true statement. So it's not the one we want because we want the one that's false. The range is 12. That's going to be from here to here. And that's false because my range would only be 10, 12 minus 2. So that's got to be my answer. The first quartile is at 4. There's your Q1. That's true. And the third quartile is at 11. That's true also. So the answer's got to be about the range.